Have you ever wondered how some businesses seem to just predict the future? Well, today we're pulling back the curtain on their so-called crystal ball. We're going to explore the core machine learning tools that turn mountains of raw data into some seriously powerful insights.
Think about it. How can a company forecast its sales with almost scary accuracy? Or how can they stop a fraudulent purchase the very second it happens? It's definitely not magic. It's a specific and actually pretty understandable set of tools.
The secret ingredient, the special sauce behind all of this, is a powerful technique called predictive modeling. It's basically a set of tools that are amazing at finding patterns in data to make these incredibly smart predictions about what's coming next. It's the engine that makes your apps feel so intelligent.
And today, we're going to break down the three essential tools: regression, classification, and clustering.
First up, you've got supervised learning. The best way to think about this is like training a model with an answer key. You feed it a bunch of historical data that's already labeled so it can learn from past examples. Then, on the other hand, you have unsupervised learning. This is where you give the model a whole mess of unlabeled data and just ask it to find hidden patterns all on its own. It's kind of like a detective showing up to a brand new crime scene with no clues.
So our very first tool, regression, falls right into that supervised learning category. And its entire job, its whole purpose, is to predict numbers.
Yep, regression models are your go-to whenever you need to predict a specific quantity. They're designed to answer questions like how much or how many. The output is always a continuous number. We're talking things like a price, a temperature, or next quarter's sales figures.
So, at its very core, regression works by figuring out the relationship between different things, like, say, how much you spend on ads and how many sales you get. It plots all your data points on a graph and then draws what's called a best fit line right through the middle of them. And that line, that becomes your predictive engine.
And trust me, you see regression absolutely everywhere. It's what's used to forecast sales revenue, to try and predict a company's stock price, and even to estimate the right price for your next vacation rental.
Okay, time for our next tool. So what happens if your question isn't how much, but which one? Well, for that, you need something different. You need classification.
Classification is also a supervised learning technique, so it also learns from labeled data. But here's the key difference. Instead of predicting a number, its job is to sort data into distinct, predefined groups or categories. You can almost think of it as a digital sorting hat.
What a classification model is essentially doing is learning how to draw a decision boundary that separates data into different groups. So, everything on one side of this invisible line might be spam, and everything on the other side is not spam. Or maybe on one side it's loan approved, and on the other, loan denied.
And this can be really simple or pretty complex. You have binary classification, which just handles two possible outcomes, like a simple yes or no decision. But then you have multi-classification, which can sort data into a whole bunch of different categories, like identifying whether an image has a cat, a dog, or a bird in it.
You actually use classification models every single day, probably without even realizing it. They're what power your email spam filter. They're helping banks decide whether to approve or deny loan applications. And they're working behind the scenes in real time to detect fraudulent credit card transactions.
All right, our final tool, clustering, is a totally different beast. This one is an unsupervised model. This is the tool you reach for when you don't have nicely labeled data and you want the machine to discover patterns that you might not even know exist.
See, with clustering, you don't tell it what the groups are beforehand. Instead, you just give the algorithm a mountain of unlabeled data, and it's up to the machine to find the natural groupings, or clusters, all based on similarity.
The way it works is by measuring the distance between all the data points. Things that are very similar to each other get grouped together, and things that are really different get pushed into separate clusters. It's all about revealing the hidden, natural structure that's already in your data, and it can often lead to those big aha moments.
And this is incredibly powerful in the business world. Companies use clustering all the time for customer segmentation, finding groups like big spenders versus occasional shoppers. It's also used for anomaly detection, like spotting weird network traffic that could be a security threat. And it's a key ingredient in a lot of the recommendation engines we use.
Okay, this simple analogy is just perfect for bringing it all together. Imagine you get a big fruit shipment. Regression is what predicts its total weight. Classification is what sorts the fruit into the pre-labeled apple and orange crates, and clustering, that's what you use when you have a pile of mystery fruit, and you need to group them by similarity, like texture and size, to discover what types of fruit you actually have.
So, we've seen all the tools. We've laid them out on the table. Now for the most important part. How do you choose the right one for the job?
Well, it all comes down to the kind of question you're asking your data. Let's break it down one last time.
This chart right here makes the differences crystal clear. Let's run through it. For regression, your output is a continuous number, it's supervised learning, and your visual metaphor is that best fit line. For classification, your output is a discrete label or category, it's also supervised, and you're creating a decision boundary. And finally, for clustering, you're discovering hidden groups, it's unsupervised, and you end up with these distinct grouped clusters. This is your cheat sheet.
And this really is the ultimate takeaway. There is no single best model. There's only the right model for the job at hand. The problem you are trying to solve is what dictates the tool you should reach for from your toolkit.